So now that we understand what this shape looks like, we're going to work on doing the integral. So the shape itself, we now know what to call this. This is the upper branch of a hyperbola. So we know the equation actually is going to suggest a lower branch down here, but because I don't have a plus or minus here, I'm just doing the top half of the top branch of the hyperbola. We also know that we could rearrange it and get the hyperbola going this way. This hyperbola is going this way. This hyperbola looks like a parabola, but it's not. So there's a lot of things mathematically that look like parabolas, but it's important to understand that they're not. So you know that a fourth degree, x to the fourth, it looks like a parabola, but it's not. It's flatter on the bottom. If you hang a string by two ends, just suspend a string, but I can't get both, but yeah. So I just hang a string like that with just a string like depending. The shape that it hangs in is called a catenary. It looks like a parabola, but it's not a parabola mathematically. It uses things like hyperbolic sine and hyperbolic cosine to describe that curve. Okay, so this is this curve. It's a hyperbola. We're looking for the area under this hyperbola. In order to do it, we need to do this kind of integral. We're going to have a different kind of substitution to use. And so when we did the trigonometric substitution x equals a sine t, we found that we needed to know what the integral of cosine squared was in order to do that. Now we're going to do a different substitution on this one, and that means we're going to need some different integrals. So along with that whole, what's the integral of sine squared, what's the integral of cosine squared, and that, what's the integral of secant? This is another background technique that's brought in together by this whole process. Something that's good to see before you get into that Calc 2 or Calc 3. What is the integral of secant x? How would I find that out? What's the integral of secant cubed x? I'm going to need that too. And that in itself is a very interesting integration technique, is how we get the integral of secant cubed x, which we're also going to need. We're going to start with this, integral of secant x. To do this one, you have to be super tricky. So one way to do it is there's a clever identity you can use, but I recently saw a demonstration of this that relies on another clever idea. So if I want to do integral of secant x dx, what I can do is take my secant x, and then a sort of trick that we do in math a lot is there's something I want, and I'm just going to stick it in there and cancel it out at the same time. So if I multiply the top and bottom of this equation by secant x plus tangent x, all right? So, and this is going to give me, because I don't know what the antiderivative of secant is, but I do know what the antiderivative of secant squared is, and I know the antiderivative of secant tangent. So what I'm going to do is sort of get those things that I know what they are, and by multiplying really by 1. So I multiply by what I want and simultaneously cancel it out, then I haven't changed what I have. So now I have the integral of, I'm going to distribute out the top, so I have secant squared x plus secant x tangent x, and then in the denominator I have secant plus tangent. So now look what clever thing we can do. Now this just turns into a u substitution, actually. So what we do is we can say, what if I let u equal the denominator, which is secant plus tangent? Then the derivative, what's the derivative of secant? It's secant tangent. What's the derivative of tangent? It's secant squared. And that's exactly what I have in the numerator, is exactly this. So what I really have here is the integral of u over du. Yeah, so we all know what that is. That's equal to the ln of the absolute value of u plus c. Now I just substitute back in my u substitution, and it equals ln of the absolute value of secant x plus tangent x plus c. All right, so now when we go to do some of these integrals on your own, there are going to be certain results that we're just going to take. Like we took our integral of cosine squared, we figured that what that is, and we incorporated it into our work. You're going to be able to do the same thing with this. Think of this as a known result. We now know what the integral of secant x is. It's this, and we can use that whenever we want. So you can use that in your homework.